what we're going to develop is the sine theta, and we're using the opposite, the adjacent, the hypotenuse to determine the sine ratio for the angle C. So to find that, what we do is we find the length of the opposite side over the hypotenuse. And I've just abbreviated that there. So sine is the opposite side over the hypotenuse. So for sine, we don't need the adjacent side at this point. Moving on to an example. The first thing we should do with any example is identify the sides. Now, as we've done before, we can find the hypotenuse is the longest side directly across from the right angle. Angle C is our angle of interest, so the adjacent side is on the bottom of the triangle, line segment DC, and the opposite side is the line segment BD, which is indicated by the length is 5. So if we do that, and we know that the sine is opposite over hypotenuse, or the length of the opposite side over the hypotenuse, we can go into the next step and fill those things in, those numbers in. So the opposite side was 5, and we found that from side BD. The hypotenuse was 9. So we can calculate, because we're dividing, just same as the tangent ratio. 5 divided by 9 is 0.5 repeating.